In this next module, we're going to spend time talking about linear and exponential modeling and using linear and exponential equations. Some of you may be familiar with linear from a previous math course, probably like an algebra course, and exponential may or may not be familiar to some of you guys. But again, in this course, we're not spending the time of looking at it mathematically and really just looking at how we apply these equations, writing these equations, and making the connection between absolute growth or decline versus relative growth decline from our unit section, or I'm sorry, our percentage section in, from chapter 3. So when you write a linear equation, these are situations that have an absolute change. And when that equation, you're going to have an output letter, and these letters should represent what we're talking about, so make it make sense. We're going to take the initial value. If our absolute is increasing, then it's plus that absolute constant change times the input letter. Excuse me. If the absolute change is declining, then we would use the minus sign. In exponential equations, these are talking about relative growth. And so this is our relative rate, where we're, and again, relative are percentages. This is a growth or a decline. So the output letter, again, is initial value. So we have to have this initial value. This time it's times 1, either it's growing, or minus if it's declining or decaying. All raised, so these are exponential. So we're going to have an exponent here raised to an input letter. And keep in mind that this relative is normally a percentage, right? But in order to use this in a mathematical problem, we have to change that relative, that percentage to a decimal. We're going to write it in 3 decimal places when we write it in our equation. Okay, so we're going to look at each one of these problems, or several of these problems, and to see what's being asked. So for each problem, identify whether it's absolute or relative. Okay, so let's do that first. So the number of students at a college increases by 450 students. Okay, and so we know that it's increasing by 450 students each year, which is the number of students. And so the number of students would represent that it is an absolute, which makes this a linear situation. Where number 2, the price of milk has been rising by 3.7% each year. And so this time we have raising by 3.7% each year. So we know that since this is a percent increase, we have a relative or an exponential situation. Okay, if we look at number 3 this time is depreciation. And in our depreciation, so that means we're going down, but we're going down by an actual 275. So that makes this absolute because it's an actual amount and it's linear. If we look at number 4, so number 4, the price of this HDTV is falling by about 22%. So that 22%, so we're falling by 22% per year. Again, that is a percentage, so that's relative, that's exponential. And then for the last one, the memory capacity of a computer is doubling approximately every 2 years. And you recall from our talk about percentages, doubling is the same thing as 100%. So we know that this is exponential while it's relative. And exponential. So now we want to go back and write those equations. And so we have the number of students at a college is increasing. for the past 4 years. Okay, so we know that we're talking about years as an input. We know that the output is the number of students, simply because we're finding, so an output is always, what are you looking for? What is your answer going to be in terms of? So my equation, so I need an output letter. So if we look back to the top, we need an output letter, okay? We need an initial value, and we need the absolute constant rate times the initial letter, or the input letter. So since we're talking about the number of students, I'm just going to call this S equals the initial value. So we need to know how many students were to begin with. And so to begin with, we have student population was 6,755 4 years ago. So it's been increasing. So we know this is where we are starting from. We know that we are increasing by 450. I mean to make that big. So we're increasing by 450 every year, so times y. So that's our linear equation. If we look at number 2 for the exponential equation, this time we need the output letter equals the initial value, 1 plus or minus, times the relative constant rate of change, but again, that's as a decimal, times the input letter. So this time, we're talking about the price of milk, and we know that the price was $2.77 2 years ago. So P equals the initial value of 2.77. And now we're going to do 1 plus, now 3.7, so that's 0.037, and we want 3 decimal places, and that's okay. So 0.0370, and then we're going to raise this, and this is happening every year. Okay, so talking about years, so we're going to raise it to the y power. All right, so for the answer, let's go back to number 1. Let's look at the answer. So what it's telling us to do is just plug in. So we have S equals 6755 plus 450 times, we want to know how many years. What was the student population 2 years into the future? So this started 4 years ago. 2 years into the future, we're going to plug in a 6. Let me do that in blue just so you can see it. We're going to plug in a 6. And then we just type that into our calculator or into Desmos exactly as you see it. And so we're just going to type in exactly as we wrote it down, 6755 plus 450 parentheses 6. And Desmos will give us the answer 9455. And so we end up with 9,455 students. When we look at number 2, we are going to plug in, so we got to see, let's see, so for 2 years it's been growing. What is it for today? So we're just going to P equals $2.70, 1 plus 0.037. You don't have to have that other 0 if you don't want to. And we're going to raise that to the second power. And so we're going to go over to Desmos. I'm just going to open a new line. I don't have to, but I can. 2.77 parentheses 1 plus 0.0337 And then now I'm on the outside. So I'm going to pull up my little bar. So I pull up my little toolbar or if you're on your phone, it's right there. You'll see you have a to the b power. That's your exponent key. We want to raise it to the second power. So we get $2.90. The 8 will make the 7 also an 8, so $2.98. Making sure we label our answers. All right. So for the following one, this time we're depreciating. Okay, so we want the value. So the value equals the initial amount, 17,250, not times because we're adding here, plus oh wait, we're not adding, we are subtracting, so let's change that to minus, so minus $275 every year. So the same thing with number 4. This time we're talking about a price. So the price equals, it's falling by 22%. We know it's exponential. So the initial price was $1477.99 times 1 minus 0.220, so that's 22%. So that's 0.22. Raised to, we're doing this every year, because it's talking about the year, so raised to the y power.